In this question, we've been given information about a car traveling on a straight horizontal road, and we've been told its initial speed. We've been told that it maintains that speed for 11 seconds. The car then decelerates uniformly for 10 seconds, reaching an unknown speed denoted by u. After that, the car once again maintains a speed. This time, the speed is u until it gets to the point B. We've been told the total distance of this journey and the total time that the journey took, and we've been asked to sketch a speed time graph to show the motion of the car. Okay, so let's just start off with our axes and with that first part of the journey. So, velocity and time. We know that it started with a speed of 28, so that speed was maintained for 11 seconds. So that'll be the first section of this velocity time graph or speed time graph. Okay, after that, we're looking for some decelerations. That's going to be a negative gradient, so a diagonal line should be drawn from here. And that deceleration occurred over a 10-second interval. So we're now 21 seconds into the journey. It decelerates from 28 down to a velocity, down to a speed of u. So I can just mark this off on the vertical axis. And now that velocity, that speed of u is maintained for, well, we didn't know how long for, but we were told that the entire journey took 37 seconds. So we can just draw that up to 37 seconds. So that's a 16-second interval. Okay, so this is the complete velocity time graph, speed time graph. The examiner's looking for two main things. The shape of the graph. We needed 2 periods of constant velocity and 1 period in between of decreasing velocity, deceleration. We needed to label the axes. So the 28 in the U, the 11, the 21, the 37. That would be enough to get you all the marks in this question. We're asked to determine the value of u. We're going to use the fact that the distance can be represented on a speed time graph or a velocity time graph by the area underneath the graph that we've produced. So the distance we're told is 700 meters. And the area, well, this is not a regular shape, so I'm going to split it into simpler shapes to work with. A rectangle, a trapezium, and a rectangle. So the area of the first rectangle, its height is 28, its width is 11. The trapezium is going to be half the sum of the parallel sides. The parallel sides are going to be the two velocities, 28 and u. So half of 28 plus u multiplied by the perpendicular distance between them, which is going to be 10. Okay, and then finally the last rectangle, will width. The width, as we discussed, is 16, while the height is going to be u. So this expression, this equation, we just need to simplify, rearrange, and solve. Okay, so in my first step, I'm just going to multiply out these brackets. I get 308. Half of 28 is 14 times 10 is 140. And then half of u times 10 would be 5u. Add that onto the 16u. Okay, let's rearrange and try and isolate u. U is going to equal 12. So that unknown velocity is 12 meters per second. Part C of the question says we should find the deceleration of the car during the motion described above. So during this journey, what is the actual deceleration? Well, we're looking at that negative gradient. I could actually just calculate its gradient, which was the first definition of acceleration that we came across. Acceleration is going to be the difference in the velocity divided by the difference in time. The difference in the velocity is negative 16. It's reduced from 28 to 12. And the difference in the time is 10. It took 10 seconds for that change to happen. That gives us an acceleration of negative 1.6 meters per second squared. And the deceleration is the magnitude of this. It is just the 1.6 meters per second squared.